This is a very simple problem. There's not much else to say. This is 21505. Find all lonely numbers in the array. Okay, so you are given an integer array nums. A number x is lonely when it appears only once and no adjacent numbers x plus 1 and x minus 1 appear in the array. Okay, return all lonely numbers and nums. You may return the answer in any order. All right, so this problem is pretty straightforward if you know the data structure involved. This is a medium, but it's pretty simple. I would classify it as an easy, really. But, you know, I suppose it's a medium because it really requires you to understand some fundamental data structures, which will allow you to execute the solution quickly. So I guess the best way to go about this is to really just think about, well, what would the brute force solution work like? If you never studied data structures and algorithms, but you could program, what would you probably do in order to solve this problem, right? Well, we just want numbers that are lonely, right? So we want to look at all the numbers and we want to find the ones that are lonely. So maybe we create this res array, and this res array is going to be the thing that contains, you know, all of the solutions, right? All the lonely numbers, okay? But in order to find the lonely numbers, we're going to have to look at all the lonely numbers, right? So maybe we look at all the numbers in nums, right? So I'm going to look at each and every individual number, and I'm going to determine, well, is this number I'm looking at lonely? Well, what would that mean for that number to be lonely? Well, if the number is lonely, it can only appear once, right? So the frequency of that number has to equal 1, okay? So the frequency of that number equals 1. Right, and another way you could do this in insufficient time, you could say nums.count of num equals 1. So the number only exists once. And there's no adjacent numbers in the array. So that would mean that num plus 1 is not in the array, nums, and nums minus num. Okay, we'll call this x because this is x here. Right, so we'll look at for each x in nums. We'll say if the count of x is only 1, we're good because it can only appear once, and the adjacent numbers cannot exist, x plus 1 and x minus 1. And if that's the case for x, well, then x would be a solution. So we'd add x. And if we run this, this should work. I'm not sure if there's a count method in Python, right, because this isn't actually going to be our final solution. And there you go. This works, right? But if you submit this, maybe it will pass, but it shouldn't because it's far too slow. Right? The problem with this is, well, you know, this is going to take n time, right? If we thought about this in terms of time complexity, right, we said, okay, let's say for the sake of argument that n equals, you know, the length of nums. Well, for time, what's the issue here? Well, we have to look at all n numbers, right? Because there's n numbers we're going to be looking at, because we have to look at all the numbers and how many numbers are there, where there's n, because n is the length of nums. So we're going to look at all n numbers. And then for all n numbers, well, we have to count how many times that number exists. So in order to do that, we're going to have to count through the entire array to find how many times that number exists. We're going to have to find if that number plus 1 is in the array, so we'll have to look through the whole array to do that. And we'll have to find if x minus 1 is in the array, so we'll have to look through the whole array to do that as well, right? So that means you're going to take n operations, right? Because you have to look at the whole array to find how many times x exists. You have to look at the whole array to make sure that x plus 1 doesn't exist. And you have to look at through the whole array again to make sure that x minus 1 doesn't exist. That's 3n operations. So for every n number, we have to do 3n operations. So that's 3n squared, or big O of n squared. So that's why this doesn't work, right? It's far too slow. The issue here is it's too slow because for all the n numbers, we have to do n operations for each n numbers, right? So if this is 10 to the 5, n squared, 3 times n squared, really, you know, that's 3 times 10 to the 10. And most Leetcode problems only allow around 10 to the 6, you know, x times 10 to the 6 if x is less than 10. So if you have something that's 10 to the 10, it's definitely going to result in a time limit exceeded issue. So what is the fundamental data structure that will make this faster? Well, you know, this outer loop takes n time. But if we could make this somehow take less time, then probably we'll pass, right? If we can get rid of this squared factor, right, this n times n, instead of have it be log n, or maybe even hopefully constant amortized constant, then we're gravy, right? So what data structure can we use to kind of see, you know, the frequency of something and if the neighbors exist? Well, what you should probably know about, right, is a hash table, okay? Now, a hash table will keep contents of a value and how many times, you know, a key and a value. And in constant time, you can check if the key exists, okay? So if we create a hash table, we'll call it X, okay? And we'll make it a default dict, so we'll call it a hash table dictionary. There's so many different ways to call things because there's instantiations, blah, 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 blah. Okay, so X is a default dict. And if we instead, we look at all the numbers and nums, and we say, well, the frequency of that number X, we're going to add 1 to it. And if this line doesn't make sense, I'll just print X out here, and you'll see what I'm talking about. Okay, so what this basically does is it creates this system where if you ask for a key, if you ask for a value, it'll tell you whether or not that value exists, and it'll tell you how many times that value exists, and it will happen in constant time. This operation, X of X, is constant. So if I say 10, this X, big X, this big X dictionary hash table has the values 10, 1, 6, 1, 5, 1, 8, 1. What that basically means is it has the values, you know, the 10 exists once, 6 exists once, 5 exists once, 8 exists once in the system. So if I did X of 10, I should get 1 because 10 exists once, right? And if I do is 10 in X, I should get true. And this is going to be in constant time because what it's going to do is it has a constant way of trying to find if that value exists. What about a value that doesn't exist in here, like 9? Let's say, does 9 exist in here? So that's 9 exists in here. False, right? So what we can do instead is say, well, instead of count of X, we can say nums, we'll call it big X of X, and that's a constant operation. And we'll say, is X plus 1 in big X and X of minus 1 not in X? If it is, then it's the case. And using a default dict, a dictionary hash table, this is a constant time operation. Checking if something's inside of it's a constant time operation. Checking if something else is inside is a constant operation. So now this is n operations. Each of we do amortized constant operations. Okay. And then we just submit that. All right. All right. All right. All right. All right. All right. Okay, so now that we have this submitted, so like I said, you know, we took that n factor and we made it now n. And then for space, well, you know, we have to keep track of all the n numbers, right? We have to keep track of how many times they, you know, we're always going to be creating some sort of entry depending on the number that we're using. Either we're going to be creating a new entry for that number or we're going to be increasing the frequency of that number. So it could, if they're all unique numbers, then there's going to be n unique spaces within this X array. So that's n space, so big O of n as well. All right, guys, I hope everyone enjoyed this video, and I hope you enjoy the rest of your evening. Peace out.